Good morning, students. Let's we discuss about the next term, that is unit cell in the solid state chapter. What is unit cell? Unit cell is the smallest unit which when repeated in 3D space generate the entire lattice. Just like if we suppose arrange this points in this way and another points just in the middle of and third line arranged repeated to first line and fourth line repeated to second line. If this type of arrangement takes place, so we can easily see how the lattice generated. So see, students, in this way generation of lattice takes place. Another lattice is like so on. So generate the entire lattice. The smallest unit which when repeated in 3D space generate the entire lattice. Just like the brick of our home is smallest unit, and when this all the bricks connected in regular manner, it will form a house like this lattice. So at first unit cell is characterized by first its edge length is like A, B, C, so on, and second interfacial angle. Interfacial angles like alpha, beta, gamma, so on. For example, most common is the cubic cell, hexagonal cell also, hexagonal unit cell. So let's we discuss about the suppose this is our z-axis, and suppose we find it is the x-axis and this will be y-axis. So student, when we form like a cubic, suppose a cube like generated, so this will become z-axis, and suppose is a y-axis, and this becomes x-axis. So x-axis, this is z-axis, y-axis and x-axis. So at first this is edge length A, this is edge length B, and this is the edge length C, and the angle, interfacial angle, this suppose this is alpha and this is beta and this is gamma. So at first we discuss about the total 7 types of crystal system and 14 types of lattice generated. How? So let's see. Student, as the edge length changed or interfacial angle also change, interfacial angle also change. So the change, and also the type of unit cell, also the type of unit cell also changed. So total 7 types of crystal systems and 14 types of lattice generated. Total 7 types of crystal system and 14 types of lattice generated. How? Depending of type of unit cell and there are 7 types of crystal system and 14 types of lattices, which is known as Bravais lattice. Bravais lattice. So let's see the different types of crystal systems. 7 types of crystal system and 14 types of lattices. Let's see. Crystal system, edges and interfacial angle. On the basis of this, let's discuss. First crystal system is cubic, in which A equal to B equal to C, and interfacial angle alpha equal to beta equal to gamma, means 90 degree. And how many types of lattices found by the cubic? Total 3 types. The name of 3 types is given in your NCERT book. So next one is tetragonal, in which A equal to B but B is not equal to C, and in which alpha equal to beta equal to gamma, and the degree found 90 degree, and there is a 2 types of lattices. Next one is orthorhombic. In orthorhombic crystal system, A is not equal to B and B is not equal to C, but interfacial angle alpha equal to beta equal to gamma is not equal to 90 degree, and the type of Bravais lattice is 4 type. Next one is number 4, rhombohedral, 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 or it is also known as trigonal, in which A equal to B equal to C, but alpha is not equal to beta, and beta equal to gamma, but it not equal to 90 degree, and the lattice form 1. Number 5, hexagonal, in which A equal to B, but B is not equal to C, but in alpha equal to beta equal to 90 degree, but gamma equal to 120 degree, and the type found only one type. Next one is number 6, monoclinic, in which A not equal to B not equal to C, alpha equal to gamma equal to 90 degree, and beta is not equal to 90 degree, and types of unit cell is 2. Next one is triclinic. In triclinic, A is not equal to B and B is not equal to C. Here alpha not equal to beta not equal to gamma not equal to 90 degree, and the number of unit cell is found to be 1. So how many Bravais lattice are found? 3, 2, 5, 4, 9, 10, 11, 12, 13 and 14. So total 14 types of Bravais lattice are found in the nature. You can learn by C, T, O, R, HMT. So in this way you can learn all the crystal systems CTOR, HMT. So student, so cubic is alpha equal to beta equal to gamma 90 degree. Tetragonal is also alpha beta interfacial angles is equal to 90 degree. Orthorhombic alpha beta gamma is also correct here, equal to 90 degree, but in case of rhombohedral, alpha beta and gamma is not equal to 90 degree. Alpha equal to beta, beta equal to gamma, but gamma is not equal to 90 degree. In case of monoclinic, in case of hexagonal, alpha equal to beta, beta equal to 90 degree, but gamma equal to 120 degree. In case of monoclinic, alpha equal to gamma and it equal to 90 degree, but beta not equal to 90 degree. And in case of triclinic crystal system, alpha is not equal to beta, beta not equal to gamma, and gamma not equal to 90 degree. So these are the type of 7 crystal system and possible types of unit cell. Here is 3 unit cell, means primitive, body center and BCC. So when we talk about the type of unit cell, we will write the name of which 3 types of cubic which type of unit cells are found in this type of crystal system. So cubic system in which primitive, body center and FCC. In case of tetragonal, 2 primitive and body center only. Orthorhombic, in case of orthorhombic, 4 types of unit cells are found: primitive, body center, face center and end center. In case of rhombohedral, only 1 primitive unit cells are found. In case of hexagonal, only primitive unit cells are found. In case of monoclinic, 2 Two unit cell, primitive and end center. In case of triclinic, only one type of unit cells are found. It is called primitive. So students, by this you can learn and remember the all 7 types of crystal systems and 14 types of Bravais lattices. Let's we talk about the types of unit cell. Types of unit cell. So simply we can divide unit cell into broadly 2 parts. The first part is the simple unit. And second part is centered unit cell. Simple unit cell and centered unit cell. Simple units further divided into only one. It is called the primitive unit cell, whereas centered unit cell further divided into 3 part. 3 part or 4 part. Number 3 part. First is the centered, so that it is called the centered body, centered unit cell, and second one is face centered unit cell, and third one is end centered unit cell. Let's we discuss in details. At first, simple or primitive unit cell. So let's see. In simple or primitive unit cell, atoms are present at the corner. So how many corner? 1, 2, 3, 4, 5, 6, 7 and 8. So atoms are present in the 8 corner. So 8 corners atoms are present. And what are the contribution of atoms at the corners? Let's we talk about the contribution. Suppose here is the atom present at the corner, and the contribution of this particular corner is only just we draw like, if we draw like this, so only half of half means half of half part of half means total. If we count the total, if one unit cell here is present, one unit cell is here present, one unit cell here is present, so one atom contributed in one unit cell only 1/8. So total 8 corner. So how many atoms present? Total 1 atom present at the unit primitive unit cell. Try to understand, students. If suppose this is the corner and atom present in this corner, so the contribution of atom in particular this unit cell is only 1/8, because here is the half part is another unit cell is go half of half, so only 1/8. If we suppose we have like this, so thus at first we draw like this, and again one by again fourth, just suppose this is the half part and one half just placed over it, so only this particular part, full circle of this particular part, this is 1 by 8th only contribution present in this particular corner, only 1 by 8. Suppose so if we cut like this, the half part is above the, or you can draw like this, half part above here. So half part above here is only the contribution is only here, because we can draw like suppose it is very difficult for draw. So suppose we cut into 4 part, 1 2 3 and 4. So how many contribution of this particular atom to this cubic unit cell? It is only 1 by 8. So 1 unit cell is above here, 1 unit cell is above here, 1 unit cell is above here, 1 below this, 1 below this. The total 1 by 8 contribution of one atom at this corner. So total corner is 8. So total number of atom present at the corner in particular simple unit cell is 1 atom. Next one is in cubic unit, as we discussed earlier, in which A equal to B equal to C and interfacial angle alpha equal to beta equal to gamma, and this will be 90 degree. So this is the simple representation of primitive unit cell. Next one is face centered unit cell. Face centered unit cell. So at first draw the unit cell. And 8 corners. Apart from these 8 corners, atom also present in each face. How many faces? 1, 2, 3, 4, 5 and 6. So just center of the face. Suppose this is the face of this side, so atom present at this center. This face is atom present in this particular center. Below this face, atom present in this center. Above this face, atoms present in this center. Here atom present, and if this is from each side, so just center of this. So all the faces in which atoms present. So contribution of atom at the face, just place here 1 unit cell, so half in this unit cell and half in this. If we draw here a 1 unit cell, the contribution of this particular half in each unit cell, half in this. So all the atom present in the face of this particular unit cell, so just count the atom as present in a corner and as well as face of the cube. Face of the cube. So we know that corner, 8 corner, and contribution of atom and each 8 corner is 1 by 8. So total number of atom is 1. Count the atom present in face. Total face is 6 and contribution half contribution of each atom, because this is contributed by another unit cell, so half, so it will become 3. So total number of atom present in the FCC, it is also called the FCC, face centered cubic unit cell. So total number of atom present in a face centered unit cell is a 4. Let's we discuss the body centered cubic unit cell. Number 3, body centered cubic unit cell. Atom present at the corner and also present in the center of the body, like this. Atom present at the corner as usual, 8 corner, and center of the body, center of the body. So at the corner and the body, the total number of corner is 8 and the contribution is, so how many atoms present in the corner? 1, and body only 1. So total number of atom present in the body centered cubic unit cell is 2. Now next, fourth number, end centered cubic unit cell. See here, end center, what do you mean by that end center? So students, atom present at the corner as well, and apart from this, end of means opposite, any opposite two faces, any opposite two faces. Suppose we draw the unit cell for end center. Any opposite two faces. Suppose this, this and this. Any two faces. Suppose we have taken these faces, just opposite to these faces. So atom present at the any two faces. Opposite, we can write here, opposite two faces. So how many? 8 corner, 1 by 8 contributions, total number of atom is 1, and opposite two faces, and as we know, two faces and the contribution of each faces is half. Just if we here draw a unit cell, just half contribution takes place, half with this and half with this. So total number of atom present in the end center is found to be 2. So in this way you can easily find that how many atoms are present in different types of cubic unit cell. In simple cubic unit cell, only one atom is present. In FCC, 4 atoms are present. In body center, 2 atoms are present, and in an end center, 2 atoms are present. So students, according to arrangement of atoms in unit cell, let's we make a chart to memorize easily. According to arrangement of atoms in unit cell. Unit cell. So at first write down unit cell, and next atoms arrangement, and atom unit cell or we call it rank of unit cell. Rank of unit cell. So at first we talk about the simple unit cell, which is also called primitive unit cell. Simple unit cell, only atoms present only at the corner. So we find one atoms arranged in simple cubic unit cell, and the atoms or unit rank of unit cell is only 1. Next one is FCC, means face centered unit cell. How many atoms at the corners? As we know, 8 into 1 by 8 equal to 1, and faces, total 6 faces, and contribution of atom is half, so it comes 3. So total number atoms in its cell, rank of the cell is 4. Next one is body centered unit cell. Body unit cell as corner 8 into 1 by 8, only one atom, and any of opposite two faces. Opposite two faces. So it comes 2 into half 1. So number of atoms or rank of unit cell is 2. Now number 4 and last, end centered unit cell. End centered unit cell, corner 8 into 1 by 8 equal to 1, and body center, any of the terms. Body center, and body 1 into 1 equal to 1. So it comes 2. Here we write any of two opposite faces. So it comes 2 into half 1. So it again come 2. So in this way you can easily memorize simple unit cell. Atoms present only at the corner, so atom unit cell present in this type of unit cell only one. FCC, atoms present at the corner as well as the faces, total 6 faces, and contribution of atom is half. So total number of atoms present in the face is 3, and at the corner 1. So total number of 4 atoms present in FCC. In BCC, any body centered unit cell, atom present at the corner, and the contribution of corner is 1 by 8, so it comes 1 atom, and in body only 1 atom present, so it comes total number of atoms present in BCC is 2. End centered unit cell, atoms present at the corner, and the contribution of the atom at the corner is 1 by 8, so it comes 1, and any of two opposite faces, so 2 faces, and the contribution of atom in each faces is half, so it comes 1. So total number of atom is come 1 and 1 2, sorry, it comes 2. So in this way you can easily find out the number of rank or unit cell present in the simple faces, body center and end center. So students, in the next video we will discuss the next topic. That's enough for today.